Have you ever noticed that ambulance sound different when it comes towards you and when it goes away? Actually, the siren doesn't change, but depending upon the relative movement between the ambulance and you, there is a change in what you hear. This simple effect is the same principle used by the radar to measure the speed. This phenomenon is called as the Doppler effect. It was proposed by Christian Andreas Doppler in 1842. In this video, we will understand what Doppler shift actually means, why frequency is increasing or decreasing with respect to the relative movement between the source and the listener, and how radar uses this Doppler effect to calculate the speed. So let's see. To explain the Doppler shift, I'm going to consider this scenario. I have an ambulance here, and one person is standing in front of the ambulance, and another person is standing behind the ambulance. So, the first scene I'm going to consider is this ambulance is stationary. So, in that case, the ambulance will be providing the sound equally in both the directions. So, the sound will be propagating equally in all the direction, and both these men will be hearing the sound equally. So let's consider this scenario here. This is our ambulance. It is producing the sound, and in order to identify the difference between the waves in front and back, I have given two colors. This is just for the understanding purpose. So the wave in front is given as the blue color and wave behind is given as the red color. So when the ambulance is stationary, you can see that the sound is propagating equally in all the direction, and both the men will be hearing the same sound. So let's consider the frequency version of this animation. So here I have taken a zoomed version of a portion of that wave propagation from the previous animation, and here you can see that this is my ambulance and which is stationary, and this is the man standing in front of the ambulance. Here you can see that the wave between these two peaks is corresponding to a wavelength. Here you can see that the wavelength in front of the ambulance and the wavelength behind the ambulance is the same. That is, the frequency of the wave propagating in front of the ambulance and behind the ambulance is same. That's why the persons behind and in front of this ambulance are hearing the same sound. So now let's consider the scenario. The ambulance is moving. So this is the ambulance here. This ambulance is moving. Then in that scenario, you can, sorry. So in, oh, sorry. So in that scenario, you can see that the wave in front is getting compressed and the wave behind is getting more relaxed. You can see that here it is more compressed, here it is more relaxed. So when the ambulance is moving towards the front, it will like compress all the waves together in the front. So let's consider that scenario in terms of the frequency. Here you can see that this is a zoomed version of that animation. Here you can see that the waves are getting compressed. That means that the wavelength is getting reduced. That means that the frequency here will increase. But when you consider the behind portion, you can see that the wavelength is getting increased. That means that frequency is getting reduced. That's why uh, the person standing in front of the ambulance and behind the ambulance are hearing different sound when the ambulance is moving. So because of this movement, these waves are getting compressed, or we can see that the frequency is getting increased in the forward direction and the frequency is getting decreased in the backward direction. That's why the person standing in front of the ambulance and behind the ambulance is hearing different sounds because of these shift in frequency. Always try to memorize this picture when you are speaking about Doppler frequency. This will help you to understand more about Doppler frequency. So if a source is moving towards the listener, the frequency will increase. And if the source is moving away from the listener, the frequency will decrease. So always remember this picture in order to have a good view on the Doppler frequency. So this Doppler shift will always hold good if there is a relative motion between the source and listener. That means that we have considered the ambulance moving case. So this Doppler shift will always happen if the ambulance is stationary and the listener is moving also. That is, the Doppler shift will occur if there is a relative motion between the source and listener. That is one of the important things that you have to consider also.